Math is super fun. Slope is rise over run. I be chillin' in the sun, yeah. Singing math is super fun.
Hey guys, Mr. Ng here. Last test of the year. Chapter 4 probability test 4.1 to 4.8 taken May 11th. Sorry, that should be May 12th. 2021. Question number 1. 1A or part A. Which of the following numbers cannot be a probability? Remember, probability is an event between 0 and 1. 1 is certain it will happen. And this is 0.5 is kind of like a maybe. This is for sure, yes, you're going to prom, maybe you're not. And you're also certain on this side that it's not going to happen. Certainly no. Okay. So no negative numbers. So that meets so that would be A. Okay, this is a number between, okay, this number is over 1. Can't go over 1, so that is not a probability. You can have 0, you can have 1. Remember, 20% is just 20 over 100. 20 parts to 100. 20%, 20 cents. Think of money. So that is a number between 0 and 1. So that's part A. Part B says a standard 6 die is rolled. Remember, you have the choices. You have 1, 2, 3, 4. Whoops, can I not count, guys? And 6. Okay. All right, find the probability that it's an even. Well, the even numbers are 2, 4, and 6. So you're basically saying probability of 2 or a probability of 4 or the probability of 6. And you can just add those. So the total and the favorable outcome that we want is there's 6 die and you want a 2. Remember, or turns into plus, so 1 out of 6, or plus another 1 out of 6, because probability of 6 there's only, out of these 6 there's only 1 of these, right? So in fractions you just add the numerators when you're common denominator, and this would give you 3/6, which is 1/2. Now this one says in decimal form, so if you put that in your calculator you'll get 0.5. 0.5. You can have 50 there too. Alright, so that was question 1B. 2A says 2 brothers, Robert and Matt, both tried out for the basketball team. The probability of making the team for Robert is 1/7. And then the probability of being on the team for Matt is 2/9. Find the probability that both of them are selected. So if you write out your words, the probability that Robert, the word both means and Matt make the team. So the word and in this case, my question is, are these events independent? They are, because if I'm the coach, assuming we're not fighting for the last position on the team, but it's kind of like, well, does my probability of picking Robert affect Matt? Now it could if you knew that maybe, I don't know, something crazy like they were the same position, like the same point guard, or they play the same center position in volleyball or something like that. But we're just trying to get them on the team, and so they are independent. And if they are, we're going to change that to multiplication. So the probability that we get Robert is 1/7, and the probability that we get Matt is 2/9. You're multiplying fractions, you can just multiply across, so you're going to get 2/63. And that would match choice C. Okay, B. A bag contains 21 toys numbered 1 to 21. A toy is drawn. Okay, so I'm going to number this. So this is kind of like my first time. And then another toy is drawn. So I'm drawing a second time. And I'm going to underline this without replacement. Okay, let's think about this. In the first one, if there are 21 toys in there, and I like to call replacement, you eat it. I know it sounds kind of weird, but you just ate the toy. So how many toys now can you pick from? In the second one, you can only now pick from 20 toys. Find the probability that both toys will show even numbers. Okay, so the word both means you're going to draw it twice. And these events are independent. I'm sorry, it is dependent. Are they independent? The answer is no, they are dependent. But what that does, all it does is basically just change the denominator. And here you can still multiply. Okay, so if you list out all the numbers, you can do this, totally fine. 1, 2, 3, 4, 5, 6, 7, 8. And did you know why I'm listing it out only in 2 columns? Well, what do you notice all the numbers on the left side are? These are odds and these are evens. Does that make sense? So I'm giving yourself a visual 19, 20, and 21. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 odds and 10 evens. So what's the probability that here in orange that I get an even, and you can think of it in there as well, and the probability you get another even. Okay, so again, the evens, there are 10 of them, but pay attention. We're assuming that on the next pick, you have one less toy, or one less even number. We're assuming that the first pick that you got is an even. Let's just say you pick out 20. Well, how many more evens are there? There are 9 of them. Sorry. To show you, there's 9. Okay, so now you can just put that into your calculator. And you're going to get 0.214. 0.214, and it tells us the hundredths. So 0.24, that's the tenths. That's the one we need, that's the hundredths. And this is the thousandths. And because that number is 1 to 4, this number stays the same. So our answer is going to be 0.21 for 2B. All right, question number 3. In a box, there are 8 reds, 7 blue, and 6 greens. One ball is randomly picked. What is the probability the ball picked is what? Not blue. Okay, there's 2 ways of finding this. You can use the probability of not blue is basically what? What are those colors? The probability that it's red or you get what? Probability that it's green. And over here you can just find the complement. And you get the same answer. Okay, so there are 21 balls, and the probability that it's red is 8/21. The word or gives me a plus, and green is 6/21, so we will get 14/21, which is 2/3. Okay, let me show you the other one. Remember, complement, if I had to summarize this, it's kind of weird, but I hope this makes sense to you. Yes plus no equals 1. The probability that I want chicken nuggets right now is 0.6. So if I want chicken nuggets at 0.6, that means probably I don't want chicken nuggets is at 0.4 because that adds up to be 1, right? Now, to find the complement, the word no, which means we're solving for no, you just subtract yes. So no equals 1 minus yes, okay? So in this case, what's the probability that I get blue? Well, the probability is blue is going to be 7/21. And there, to make 1 a fraction, you put it over 1, and then you're going to multiply by 21. Because 21 divided by 21 is 1. And you subtract those, you just subtract the numerator, which gives you 14/21, which is the same thing. Now, it's telling us again, round to the nearest hundredths place. So 2/3 is the same thing as 14/21, and if you put in your calculator, you'll get 0.67 is your answer for question number 3. All right, question number 4 says, the following table gives us a set of outcomes and their probabilities. Let A, or event A, be the event the outcome is less than a 3. Find the probability of A. Okay, what is a number less than 3? That would be a number 1 and 2. The reason why I'm not including 3 because it does not say the outcome is less than or equal to. Okay, so I basically want the probability of a 1 plus the probability of a 2. Well, you already have that. This would be 0.1, and the probability of a 2 is going to be a 0.3, and you get basically 0.4. Now you could have done something like this. You could have done the complement. Sorry, that's messy. And basically, you want the probability of 2 that the number is greater than 2, which is 3 and 4. Or if you did the complement, a number that is greater than 3. So that's the same, or you could do probability of x is greater than 3, right? And then just do 1 minus. Because this will give you the probability of a number greater than 3, greater than. That should actually be greater than 2. I was going to say equals 2, but it's easier to understand if it was greater than 2, which is a probability of 3 plus 4. And then you just find those two and then subtract it from 1, you'll get 0.4. Question number 5, I didn't have the nice looking chart or two-way table, so I just put one on here. A survey was conducted to determine whether a group of 11th graders and 12th graders prefer to go to an amusement park like Knott's Berry Farm or the zoo for a class trip. The results are shown in the table. All right, you guys did this for classwork 144, and something we don't have is the total. So if you just add those down, you're going to get 56, 44, and the nice thing is equals 100. And if it did in this direction, you get 40, 50, and 50. Okay? Based on the table, what is the probability that a student preferred a class trip to the zoo given they are a 11th grader? Okay, this is conditional probability. And if you're not great with the formula, which is fine, all right, the formula is probability of A given B equals the probability that A and B all over the probability of event B. Okay, what does that mean? So, get different color here. The event B is the given. So given is right here. So this part is 11th graders. What's the probability that given they're an 11th grader, so that's my denominator, that it's they want to go 11th grade and zoo. Let's see if I can get another color. The probability of 11th and the zoo. So here's 11th and the zoo. So that would be this number, 18. So 11th and zoo. So the probability that you're an 11th grader would be just looking in this row here. So you're starting with only 50 of them. Okay? So that would be my answer. Now you can pick any of these. It doesn't tell you, so you can use a fraction. You can reduce it. So 99 to 25. Or if you put that in your calculator and round into the nearest tenths, you would get 0.36. Okay? Alright, question number 6. A deli offers up to 12 different toppings on their sub sandwiches. How many different topping sandwiches are possible? Alright, so here is my total, which is your n value. So n equals 12. Okay. My last one, how many of these 4 topping sandwiches can I pick from? You're going to use a k value that is 4. Now here is the most important question. Does order matter? Okay guys, I gotta tell you, I don't like pickles, I don't like olives on my sandwiches. But I don't really care. I love avocados, onions, turkey sounds great right now, and bacon, right? So does it matter really to me it doesn't really matter. So in this case, the big idea is that order does not matter. And if it does not matter, then it's a combination. Remember the videos I talked about, like you go to a fast food McDonald's, it doesn't matter how you get your burger, your fries, and your shake, you want it, right? Okay, so if order does not matter, then your formula is going to be NCK equals N prime N minus K prime and then K prime. If your N value is 12 and your K value is N value is 12 and your K value is 4. So get 12 factorial and then you're going to get 12 minus 4 and 4. So this will give you 12 factorial over 8 factorial, 4 factorial. So 12 times 11 times 10 times 9 times 8 times 7 times da da da. over 8 times 7 all the way up down to 1. And then 4, 3, 2, 1. So then your 8s and all that will cancel, and you're just left with that number. So if you multiply those numbers, you will get an answer of 495. Okay, let's show you how to do that with the calculator. So math, PRB, probability, NCR. So you have 12 toppings to choose, and you're choosing only 4 of the 12. Order does not matter, 495. Which would be choice B. 6 is B. All right, number 7. Classify the following events as either dependent or independent. I'm doing my taxes right now, and here's me and my wife, and then all of our little bunnies. I think I'm going to the hospital tonight to deliver bunny number 6. Okay, so all these little guys, all these my little rabbits, all my kids are dependent. They depend on me to give them food and shelter and give them love and guidance, right? But if these guys all get older, you know, they're going to be pretty much the same size as me or bigger. And let's just say this is my wife and I now. They got big, right? They don't need me. They're going to leave. And they're not going to ask me for any more money. They're going to be independent. Their choices do not affect my choices. Okay? All right, I'm just going to label this A, B, C, and D. Okay, so let's go ahead and just think about these. You flip a coin 2 times. So on a coin, you have heads or tails. And if you flip it 2 times, does that mean the first time, let's just say you pick a head, does it affect what's going to happen on the second time? And the answer is no. Right? The probability doesn't change the outcome. 1 over 2 is still going to be, for heads, 1 over 2, 50%, right? So this would be an example of an independent event. That would be the first one. Okay. A box contains 5 purple marbles, 3 green marbles, and 2 orange marbles. Draws are made without replacement. We talked about this, guys. If you replace it, so let's just say here's the example, right? What's the probability that I pick purple twice? This would be 5 out of 10. Okay, if I replaced it, meaning I pick a marble and I put it back, replacement, that would be 5 out of 10. Okay, that would be independent. Why? Because the numbers there haven't changed, basically. But this one says without replacement. You eat the marble. You're so hungry in class, you eat it. Well, if the first one is a purple, then you eat it. How many purple are left inside the bag? There are only now 9 of them. And this is an example of dependent. The second time you pick a marble is dependent on the first one. So I'm going to put a B down there. Okay. You flip a coin, so it's either heads or tails, or you roll a die that has the 6 numbers, right? Does the left side affect the right side? The answer is what? No, it does not affect. The die, if I roll a 3, is not going to help change the probability that I'm going to get like heads or tails. So C is they are independent. Independent events. They do not depend on one another. They don't affect each other. They're independent. They stay the same. Okay, the last one. Lunchbox contains 3 kinds of sandwiches, and every time draw one of them randomly to eat it. Okay, so let's see. I have, I don't know, tomato, lettuce, and bacon. And the first day, I pick randomly bacon. And then on Tuesday, I pick lettuce. And then on Wednesday, I pick tomato. Well, the first time I pick it, I had 3 to choose from. So I had a 1/3 choice. But then the second time, there's only 2 boxes to choose from. So that's 1/2. And then the last time, you're going to get the leftover one. But basically what I'm trying to say is that your probability changes each of the days because there's no new lunchbox. Okay? So that one is going to be D. Monday's outcome affects Tuesday's outcome. It doesn't say it's replenished or the cafeteria lady put it there or, it's gone. So that is problem number 7. All right, question number 8. Hannah is playing the lottery. She can pick 5 numbers. I'm going to write K equals 5. And now, from the numbers she can pick from, the total is 1 to 40. So this is your n value equals 40. Okay, here's some clues. No repeating numbers. And order of these numbers does not matter. Combination or permutation? That would be a combination. So N, C, K. Now what this formula is going to do is this is going to find the total ways that you can get the winning number. Okay, so if I just put that in there, you can do that by hand. N minus k factorial. So you would have 40 minus 5 factorial. So 40, 39, 38, 37, 36, 35. That would be the 40 factorial. And then this would become 35 factorial. And then the green is 5 times 4 times 3 times 2 times 1. And of course, we'll just double check with our calculator. Those will cancel. Math, probability, combinations. 40 numbers. You're going to choose 5 to give us the winning number. 658,008. And remember, there's only one winning number. So my probability is going to be 1 over 658,008, and that would be choice D. And those are the Chapter 4 test corrections. See you guys.
Math is great, math is okay. You will need in life every day. From pandas to functions, to fractions, to formulas. You will need in life every day. We need math.